Right, everyone, welcome to another awesome lesson. Yeah, we're going to be doing some grade 11 questions on exponents and equations. So I'm just going to be picking a few questions that I believe they are important for you to know as a grade 11 learner. So first thing first, we need to define our exponents, exponential laws. Exponential laws. I'm going to only highlight the laws that are very, very, very important for you to know. The first one, we know it. When multiplying powers of the same base, we do what? We add exponents. Law 2. When dividing powers of the same base, we do what? We subtract the exponents. This is like grade 1 work. But it's very important that you know these principles because of if you're struggling with this, it's going to be hard for you to see it on a question. So you should know if it's multiplication, usually it's going to be something like this. Then once we know we're multiplying the bases, we should be able to add the exponents. Is it clear? I don't think this is clear. Yes. And then for the second one, once we have a fraction like this, we know that we have to subtract. So another thing, if I can give it, write it like this. Let's say already the exponent at the bottom was a negative, meaning if I were to write it like this now, it's going to be a negative and a negative, which is going to give me a positive because of already it was a negative, and according to this rule I have to subtract the exponents. So if you get a negative exponent as a denominator, you must expect it to change sign as it goes up. Then if you have a bracket, power raised to a power, you need to multiply the power. So we're going to do this quite often. When we change a number to be a prime base, the base and the exponent that we get from changing to prime base and the exponent that was there initially should always multiply together. If there are two numbers there, they should multiply together. I'll give you an example. Let's say we were given something like this. X plus 1. We're going to change the 4 and make it a prime base, which is 2 squared. Are we all clear? 2 squared will give us a 4, but outside of this we have x plus 1. So according to this law, I have to multiply both the terms outside by the 2, such that my answer will be 2 squared plus 2. A lot of people always forget to multiply with the 1. They multiply with this one, but this one they leave it as 1, of which it does not really work out to be a correct answer at the end. So another law that we have, when we have a product, we can multiply everything out like that, or we can do vice versa. We can move from here to there, or put this out as a common factor. We can factor out an exponent. Is that clear, everybody? And then same as division. So for this one, even when we are given something like this, we can distribute the exponent. Each base will have that exponent. So division and multiplication works almost the same. And then we've got definitions that we need to know. Main definition that I love so much is on this one. When we are given a negative exponent. When we're given a negative exponent, it's always going to be a fraction like that. It's going to be 1 over. Am I right? 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 So if we have this, we can move from there to there, we can move from there to there. Meaning if I was given 2 to the exponent 1, the negative says we can make this a fraction, and then like that. 2 exponent 3, what is it going to be like? Look at this. The exponent goes together with the base at the bottom. This negative only tells you that we've got a fraction. So it's going to be 1 over 2 to the 3. Is that clear? For stand J? Okay. And even if we're given something like this, no, sorry. If we're given a fraction like this, I can change this to write it as a negative exponent. So I'm going to change first this, and then this 1 over, you see here, the 1 over becomes a negative. So I can have this, I can write it as that. So this is a very important principle, especially when we're dealing with exponential equations. You need to know that question. Alright, moving along. Can I put the other law here? Anything raised to the power of 0 is 1. So I think with these tools, guys, you need those 4 laws of exponents. And with this also, you can be able to tackle any question that you face. So I'm going to continue from there to doing questions. Now let's do questions now. Let's do questions. So the first question that we're going to be doing now is this one. So 4n plus 2 dot n minus 1 over 72 n to 1 minus n. So what's the first thing to do? The first thing is to always change all your questions to your bases to be prime bases. And how do you do that? We use a calculator. Calculator does that for you. So what is the prime base for 4? 2 squared. So in the place of 4, I'm going to write 2 squared n plus 2. What is the prime base of 9? 3 squared. Put it inside brackets because of what's outside. Over prime base for 72. Can you see? 3 cubed multiplied by 3 squared. So 3 cubed multiplied by 2 squared. Am I right? No. 2 cubed multiplied by 3 squared n. And this one is already a prime base. I don't have to change it. Are we together? Together? Yes. Okay, moving along. So I'm going to apply law 3 that says I need to get rid of this bracket by multiplying out. So I'm going to multiply everything here by 2, everything here by 2. I'm going to multiply this in. Remember law 4. So my answer is going to be 2n multiplied by 4. 2 multiplied by 2 is 4, 3, 2n minus 2 over multiply 2, 3n. You can write it like that. Okay, are we fine? Then from here, I'm going to apply law 1 and law 2. Law 1 says if I'm multiplying parts of the same base, I can add the exponent. So there's nothing on top, but I can subtract this 2 and that. So I'm going to subtract minus 3. I'm going to subtract 3n and subtract 1 minus n. So it's going to be 2n plus 4. 3n, I'm going to subtract it according to law 2, is going to be negative 3n. This one, it goes up, is going to be minus 1. This one is already a negative. If it goes up, it's going to become a positive because of what I showed you there. So, and then What about this one? 2n minus 2. I'm going to subtract this one here, minus 2n. And then I'm going to start my cancellation process. 2n multiplied by n is going to be 3n. 3n minus 3n is going to be 0. It goes away. And 4 minus 1 is how much? 3. Let's go to this one. 2n, negative 2n. It cancels out, and then we are left with a negative 2 there. So what's really the answer here? The answer is going to be 8. And then this one, we can change it, guys. You still remember. You can write it in this form: 1 over 3 squared. If I want to write it as a positive exponent, the negative tells me that this is going to be a denominator. So 8, 1 over 9, which means my final answer is going to be 8 over 9, something like that. Please check if everything is correct. You can pause and check and do the question yourself, then come back and check your answer. Okay, wonderful, wonderful, wonderful. Let's do a question where we have to factorize now, when we have addition or subtraction in between. All right. Click this question. Question 2, 3x plus 2 minus 3x over 3x plus 1 minus 3x minus 2. So once we have a negative or subtraction in between the exponent, the basis, we know that we're going to factorize. We're going to factorize somehow. Now, I want to bring to your memory law 1. Law 1 says if I'm multiplying same basis, I'm going to add the exponents. Meaning, for this to look like this means before it was like that. So other people, they call it expansion, but I call it reverse of law 1. I mean, we're going to the back. This, before it can look like this, each exponent had its own base. So I'm going to write it like that. So meaning this was 3x dot 32 minus 3x over 3x dot 31 minus 3x dot 3 negative 2. You all understand, I believe, how I'm expanding all of that. So the only one I don't have to expand is this one, because there's only one thing there. The rest I had to break it down, reverse law 1 or expand, whichever way you know it. Then I'm going to take out a common factor. On numerator, I've got 3x and 3x, so I'm going to take 3x out as a common factor. If I take 3x out as a common factor, here I'm left with 3 squared minus 1. If everything goes away, we're left with 1, not 0. And then underneath, common factor is 3x again. Take out 3x, what am I left with here? 3 minus 3 negative 2. So once you're here, the calculator does the job for you. Press this whole thing in the calculator. You can work it out. 3 squared is 9, 9 minus 1 is 8. But make your life easy. Whatever that's inside of the bracket, just press it on the calculator. They won't know. Nobody will ever know. This is going to cancel out. And then this, press it on the calculator. See, you get 8. At the bottom, press that on the calculator also. 3 minus 3, like that. 26 over 9. Then press the whole thing on the calculator. 8, 6 over 13. So you won't lose marks as long as you make sure that you show all the steps. So you show that this numerator part, that's the answer, this part is here. So if you try to work it out, it might get messy dealing with fractions and negative numbers there. But just calculator, put the answer there, press the whole thing, and then voila, or voila. The most important thing, you need to know how to break this down, factorize. Once you are here, the calculator can do it for you. Yes, we're moving along because of, just want to give a quick summary. So let's do equations. Exponential equations. Exponential equations. So remember exponential equations. If you are given something like this, 3x equals to 9, your aim is to get rid of the bases so that we can equate the exponent. So 3x equals to, change this into a prime base, it's going to be 3 squared. And then once we are at this stage, so always change to a prime base. Your aim is to get the value of x. We're solving for x. So once the bases are the same, we equate. So once the bases are the same, drop the bases and equate the exponents. So we're going to drop this and then just equate the exponents. So meaning x is 2. If I put a 2 there, I should get 9. So same principle applies, just that now we just have to add some spice to the thing. So the first question we're going to do, I'm going to pick 2 or 3 questions on this one, and then we should be done with the lesson. So let's pick a question, pick a question. Let's do this one. 9 plus 1 equals to 27x. So what's the first thing to do? To change the bases to be prime bases. 9 is not a prime base, 27 is not a prime base. So your aim will be to change these things to be prime bases before anything else. So here we can change that, and there we can change that like that. Alright? Then the second one, root 3 of exponents, bracket means multiply out. So I'm going to multiply that, so I get 2x plus 2. On the other side I get 3x. Are you all clear? Now, the bases are the same. Do you all agree? Yes. So we can drop the bases and actually equate the exponents. So I'm going to take the like terms to one side. I can move this to there, since it's the smaller one. It's going to become negative. Positive goes across the equal sign, becomes a negative. Then I have 3x minus 2x, meaning x is 2. Are we all clear? You can actually take this and check if the answer is correct. It should work out to be the same. Yeah, it should be the same. Okay, I hope we are still fine so far. I wanted to test it. You see, if you put 2 there, by the 9 you get 7 to 9, because the 2 plus 1 here, 2 plus 1 is going to be 3, and then 27x, let's see if it's going to give us the same answer. Yeah, there you go. Cool. Let's do another question. Which question are we doing now? I want to do this one. 2x equals to 1 over 16. Let's do that question. And then are we picking any other question after this one? Yes, let's do this one also. Interesting. Yeah, we'll see it when we get there. So let's do this one first. The first thing, change this into a prime base. So 2x equals to 1 over 2 to the 4. And then we have a law that says if we are given this, we can actually write it as that. So we have it as a fraction, we can make it a negative exponent. So meaning this is the base, this is the exponent, and with a negative. So meaning like that. Can you all see? If the bases are the same, we equate the exponent. So x equals to negative 4. 100%. Yes. Wonderful. So if you ever get a question like this is how you should deal with it. Change the fraction to look like a power, base and an exponent. Wonderful. Let's do this question. So here, let's see what's going to happen. The first thing that I will do, I will expand this one, reverse of law 1 here. So let's see, 2x minus 6, 2x 2 1 plus 2. Okay. What else can I do? I can't do much, but I can multiply these two together. So this, I can change it into a fraction, it's a half. So a half of 6 will be how much? 3. So 2 squared minus 3, 2x 2. Now that, are we all clear? You can check that, see, you get a 3. So here, what we're going to do, I see that I'm going to have to factorize. This is going to be a trinomial because I've got 2 x's there and I've got 1x. So there are 2 ways to do it. This is where we introduce the k-factor method, where you let k. So I think I'm going to do the last question. This is the last question. So I'm going to do it 2 ways. See if you can get it. Look, if I write this like this, 2x, and I put a square outside. Do you agree that this looks something like this? Because look, I've got this thing here squared, and I've got this thing here squared to the x. So it's similar. So if I write it like this, I've got a trinomial. Do you all agree? I hope you see it. And if I were to factorize this, what are the factors of 2 that will give me 3? That's 2 and 1, and they're both minus minus. You get it? So this means I can actually write, in the place of k, I can write 2x minus 1 and 2x minus 2 equals to that. Can you all see? I hope you see it. Then I'm going to equate each bracket to 0. The zero factor principle or element. So 2x minus 1 equals to 0, 2x minus 2 equals to 0. And then take this one to the other side, 2x equals to 1. Or 2x equals to 2. So this one, it's nearly done because I know here there's an invincible 1. So I can drop the bases and then say x for this solution, x is 1. But I still need to do this one. How do I change 1 to have a base similar to this. Remember that anything raised to the 0 is 1. So I can actually write 2 to the exponent of 0. It will give me 1. Because what am I doing? I'm trying to get the bases to look the same. And if the bases look the same, I can draw the bases and just equate the exponents. So that's the solution for that one. So x is either 0 or x is 1. For this, we have 2 solutions for this question. Take it slowly, slowly. We call this the K method. And try questions like this on your textbook. If you have any questions, shout. Let me see if we can pick any other question. Okay, and that's it on exponents, I believe. Thank you. Bye.